All right, hello everybody. Today we're going to do the second day of graphing exponential functions. All right, and yesterday we did slides. All right, where we just shifted the graph right, left, up, and down. Okay, today we're going to talk about flips. All right, now just to review real quick. All right, an exponential function. All right, is we have some base raised to a power that has an exponent in it, has a variable. Sorry, it has a variable in it. Okay, so y equals 2 to the x, it could be y equals 3x, 4 to the x, whatever. All right, remember when we are graphing, we want to graph 2 points. We want to put the asymptote. So the basic shape has a horizontal asymptote at 0. All right, it has all of them have a point at 0, 1. And we are going to use this case, it would be at 1, 2. All right, because if I plugged in 1, I would get 2 there. Those are your 2 points. All right, that is the basic shape of y equals 2 to the x. Okay, now we talked about if yesterday that if we had numbers up in here in the variable, we set that equal to 0. That slid the graph to the left or to the right. If we had numbers off to the right by itself, that slid the graph or shifted it up or down. Sliding or shifting, they mean the same thing. Okay. Now today we're going to talk about flipping. There's going to be 2 types of flips. We're going to have a vertical flip and a horizontal flip. All right. So the first one we're going to do is a vertical flip. All right. A vertical flip is whenever you have a negative on the outside of the function here. All right, which we have here. All right. So this is going to be a vertical flip. All right. Not the best handwriting. I apologize. All right. That is a vertical flip. Now, when we do a vertical flip goes over the x-axis. It goes over the x-axis. We're going to flip it over the x-axis. All right. So let's take a look at what this is going to look like. All right. So whenever you see this negative out in front of here, that is an indication that we have a vertical flip. Now notice there's just an x here. It's not x minus 1, x minus 2. So there's no sliding it left or right. There's no number over here. So there's no sliding it up or down. All right. So that means the horizontal asymptote stayed at 0. Okay. Now what's going to happen is this. So normally, all right, we have a point here at 0, 1. So we're going to flip it over the x-axis. So it gets flipped. And since it was 1 above the horizontal asymptote, now it's 1 below. All right. It was, so this point was 0, 1. Now this point is 0, negative 1. All right. So we just changed the sign here of the y coordinate. Right. That's all we're doing. Change the sign of the y coordinate. It was at 0, 1 and now becomes 0, negative 1. We flipped it over. Okay. Our other point is normally right here. Right. So we had this point here that gets flipped here. We had this point. Now this was at 1, 2. If we flip that over, that's going to be at 1, negative 2. Right. And our graph now looks like this. All right. So this is what we call a vertical flip. It was on the top. Now when it's a vertical flip, now the graph is on the bottom of the asymptote, right? So this graph I'm showing you now, this is what the original looks like. This is the basic shape of y equals 2 to the x. All right. And you can see it's just got flipped over the x-axis. This is a vertical flip. All right. Vertical flip. Now let's talk about something else. Let's talk about what the domain and range of this is going to be. All right, the domain everyone should know is what? Well, it's always going to be negative infinity to infinity. Now, the range, since we have everything below the asymptote, it's going to be from what's the smallest it is, it goes to negative infinity up to the horizontal asymptote, which is 0. Okay, so your range, if you notice now, has either been whatever the horizontal asymptote is to infinity. If it's above, if it's below, it's going to be negative infinity to the horizontal asymptote. All right, so this is a vertical flip, a flip over the x-axis, right? Over the x-axis. All right, so we were at 0, 1, at 0, -1. We were at 1, 2, we flip it, it's at 1, -2. All right, so the other type of flip is when we have a negative in front of the x. We have a negative in front of the x in the exponent, okay? So this is what we call a horizontal flip. Okay, and you could probably guess that a horizontal flip, if a vertical flip, we flip over the x-axis, a horizontal flip, we flip over the y-axis. All right. All right, so what's that going to look like? Okay, so we still, there's nothing here, right? There's no other numbers in here. So if we set this equal to 0, it's still 0. All right, so we're not shifting it left or right, sliding it left or right. If there's no number here, so it's not getting slid or shifted up or down. So the asymptote, horizontal asymptote, is still going to be at 0. All right. Now we normally would have a point right here, right? At 0, 1. Well, 0, 1, if I flip it over the y-axis, I'm on the y-axis. Guess what? It stays on the y-axis. It doesn't move anywhere. All right. It doesn't, we're not changing it. All right. It's on the axis that's flipping over. It stays there. The other point was here, right? It was at 1, 2. If I flip it, all right, over the y-axis, it's just going to move over to this side, which is going to be right here at -1, 2. So it was at 1, 2. I'm now at -1, 2. So basically all I did was change the sign of the x-coordinate. Here, I was changing the sign of the y-coordinate. Here, I'm changing the sign of the x-coordinate, right? So then I just, let's change the color here. And there's my, it's not the best looking graph, but you get the idea. And there it is, all right? So it looked originally like, this is the blue one again. Once again, the light blue one here is the basic shape, y equals 2 to the x. This is y equals 2 to the x. This is y equals 2 to the -x. It flipped over the flipped over the y-axis. It is a horizontal flip, all right? Horizontal side to side. So it went from being on this side, flipped it over to that side. Verticals up and down, went from the top to the bottom. Notice it's still above the x-axis, which means, change colors, confuse here. The domain of y equals to the -x. The domain is always for all these -infinity to infinity. The range, since everything is above, it's the horizontal asymptote, which is 0 to in positive infinity. All right. So when a negative's out front, that is a vertical flip. We flip it over the x-axis. All right, which just means that you're kind of just changing the sign of the y's. All right. Here, when you flip the horizontal flip, all right, you're flipping it over the y-axis, which means you're just changing the sign of the x. The y coordinates are staying the same. All right. All right, so let's look at a few examples. Okay, now we're going to incorporate our shifts, our slides in there as well. Okay, so there's 4 things we basically, every time we look at one of these problems, we're going to look for. We're going to look for if there's flips, which means is there negatives in front or negatives with the x? Is there another number up here in the exponent? And is there a number by itself off to the right? Those are the 4 things we're going to look for. Negative out front means it's a vertical flip. A negative in front of an x would be a horizontal flip. A number up here shifts it, slides it left to right. A number off to the right here slides it up and down. Okay, so we see, I'll change color here for a little bit. This thing right here, what does this do? This is a vertical flip. All right, I'm just going to put VF for vertical flip. All right, that means we're going to flip over the x-axis, which means our graph is going to be below our asymptote. This is a slide or a shift. Which way? Well, it's going to be set that equal to 0. That makes it 1. It's a shift of 1 to the right. All right, shift of 1 to the right. Okay. Now, since there's no shifting up or down, that tells me that my horizontal asymptote stays at 0. All right. If it was a +1 over here, then it would be at 1. If it was at 2, it would be at 2. Okay. So we have a horizontal asymptote is at y is equal to 0. Now, we normally have a point at 0, 1 and at 1, 3. Why is it not 1, 2? Because our base is 3. All right. Those are our normal points. So if I were to take 0, 1, and I'm going to, two things are going to have to, I have to flip it, and then I have to shift it to the right one. Okay. So what you want to do first is always do your flips first. Always flip it first. All right. And then slide to the right or left. All right. So we're going to flip first, then we're going to slide or shift. So if I was at 0, 1, all right, and I'm going like this, so then I'm going to flip it, which means I'm going to be at 0, -1. And then if I shift it 1 to the right, I'm going to be right here at 1, 1. So I flipped it. It came here. I slid it 1 to the right. It's there. Okay. Now, my other point is normally here at 1, 3. Excuse me. So if I flip 1, 3, flip it over the x-axis because vertical flip, it then goes to 1, -3. Then I'm going to move it 1 to the right. All right. And that's right there. And this point is 2, -3. I then, whoops, as I look at my kid's Netflix. All right. And it looks like that. All right. Sorry, my graph got screwed up here with it, but you get the idea. All right. Going towards the asymptote. So the original shape looks like this. It makes sense that it's on the bottom because we have a vertical flip, and it just got shifted over 1 to the right. All right. Now, if we're going to do the domain of this, the domain is always what? -infinity to infinity. The range, it's on the bottom, which means we're going to go horizontal asymptote. It's either horizontal to infinity or -infinity to horizontal asymptote. It's on the bottom, so it's going to be -infinity to a horizontal asymptote, which in this case is 0. Okay, so two things happened. We had a flip and we had a slide of 1 to the right. Flip first, slid it to the right. This point here, 0, 1, flip to 0, -1, we slid it to the right, 1, 1. We're at 1, 3, we flipped it down to 1, -3, slid it to the right to 2, -3. All right, on to the next. All right, so number 2, we have E. Now remember, E is roughly 2.718. You just need to know that so you can graph it roughly in the right spot. I don't even need to see hash marks anywhere. You don't need to do that. But it gives a little better idea, but it should at least be in the general right spot. You don't have to, when you label point, you don't have to put 2.718 and then add 1 to it. If you have to do that, just leave it as E. All right. All right. So let's look for the things we have to look for. First, is there any negatives? Well, there's not a negative in front, so we do not have a vertical flip. There is a negative in front of this X, which means we are going to have a horizontal flip. All right, so we're going to be flipping over the y-axis in this problem. And we have a number out here by itself. That it's a +1. That means we're going to shift this or slide this up 1. All right, this is going to go up 1. All right, now for an exponential, this number here gives us our what? It gives us our horizontal asymptote. All right, so let me just do a few of these real quick. I'm going to sneeze. So our horizontal asymptote is going to be at y equals 1. All right. So we have two things, like I said, horizontal flip, and we have a shift up 1. All right. So our basic shape of y equals e to the x. Y equals e to the x is just like 2 to the x, but instead it's at 0, 1 first, and instead of being at 1, 2, it's at 1, e. So if we were at 0, 1, which is this point right here, if I do a horizontal flip, well, the x coordinate, when you're at 0, you can't change the sign. You can't flip over the y-axis, all right? So the only thing you have to do is move up 1, all right? And there is our new point for there. So that's at 0, 2. All right. Now, my other point was at 1 comma E, right? 1 comma E, which is somewhere in this area here, right? 2.718 is like right here. So if I shift it as do a horizontal flip over the y-axis, instead of be at 1 comma E, I'm going to be at negative 1 comma E, and then I'm going to move up 1, which is like right here. Now that point, the way we can label it, it's negative 1. And if I did E plus 1, that's roughly 3.718. Don't have to write that. Just write literally E plus 1. All right, and then draw your graph. All right, so you went from something that was something going up this way to now decaying this way. All right, and that, if you want to label this point, that is at 0, 2. All right, so we did a horizontal flip. We flipped it over the y-axis, and then we shifted up 1. We were at 0, 1. When you do a horizontal flip, it stays there. We just slid it up 1. We were at 1 comma E. We flipped it. It was at negative 1 E, and then we went up 1. So it's negative 1 comma E plus 1. All right. The domain of this one would be, once again, negative infinity to infinity. The range, what is the range? Well, it's above. It's going to be from the horizontal asymptote, in this case, is 1 to infinity. All right, range is 1 to infinity. All right, so next example. All right, we have, we have y equals 1/2 to the x minus 1. All right, now we have a 1/2, remember. So this is a little bit different of a basic shape. All right, it still is at 0, 1. But instead of going up like this, it's going to be going down like that. All right. And instead of being at, this would be at negative 1, 2. All right. 0, 1 and negative 1, 2. Instead of at 1, 2, it's at negative 1, 2. Okay. So what kind of movements do we have here? Well, we have a negative out in front, which means we are going to have a what? A vertical flip. And then we have here a negative 1 out there by itself. This is a slide. This one's going to go down 1. All right. There is no negative in front of the x, so there's no horizontal flip. There's no number up here, so there's no sliding right or left. All right. Remember, with exponentials, whatever this is going to be our horizontal asymptote. So we have a horizontal asymptote at negative 1. We have a vertical flip, which means our graph is not going to be above the above the asymptote. It's going to be below. All right. So let's just label a few points here. Okay. So we have normally, right, 0, 1 is a point, 0, 1. So we have a vertical flip that would put it at 0, negative 1. So it's a vertical flip that flips over the x-axis. Then move it down 1. So we're at 0, negative 2. All right. We would be at negative 1, 2. We do a vertical flip. We're at negative 1, negative 2, and move down 1. So we're at negative 1, negative 3. And we have our graph that looks like that. All right. So this was the shape. You can see it gets flipped over. So it looks like that. And then everything got shifted down 1. All right. Our domain, once again, is negative infinity to infinity. Our range for this one, it is below. So it's going to be negative infinity to whatever the horizontal asymptote is, which in this is negative 1. Domain negative infinity to infinity, range negative infinity to negative 1. All right. Last one. All right. We have we have a bunch of stuff going on this one. All right. So we have a negative out in front, which means we have a vertical flip. We have a negative in front of the x, which means we have a horizontal flip. All right. So we have both flips. We have a negative 2 up here at negative x minus 2. Now, if I set that equal to 0, what makes that equal to 0? Well, if I did negative x minus 2, and set that equal to 0, I would get negative x equals 2, which means x is equal to negative 2, which means we are going to go move to the left 2, right? Because negative 2 would make that equal 0, so we move to the left 2. And this right here means we're going to go up 2. All right, so we have a lot going on. Now remember, y equals 2 to the x. That's the basic. 2 to the x is just our normal 0 point. Looks like that. Our points are 0, 1 that we would use, and 1, 2. All right, so let's scroll down here a little bit. All right, so remember when we do this, and let's just label some points here. Just, all right, make this a little bit easier to do. Okay, we have a horizontal. I always like to put the horizontal asymptote. You don't have to, but I like to put that there first, which is going to be at 2. Because I know that my points in my graph, since I had a vertical flip, should be below this. If it's not, I know I made a mistake. Okay. So remember, and it's a shift up 2. The horizontal asymptote is normally 0. It just got moved up 2. Okay. Now, to figure out there are 2 points. We are normally at 0, 1. All right. So we have 4 things that are happening. We have a vertical flip, a horizontal flip. We have to move it to the left 2 and up 2. So a lot going on. Okay. So a vertical flip at 0, 1 moves me down to 0, -1. All right. A horizontal flip, flipping over the y-axis, doesn't move it. So I'm still at 0, -1. I then can move to the left 2, which I should put these here. All right. So I'm going to move, I'm at 0, -1, move to the left 2. So I'm at -2, -1. And then I got to move up 2. So I'm at -2. So this is going to be -2, comma 1. We're at -2, comma 1. All right. Notice we're always normally 1 above the asymptote. Now we're just we're always kind of 1 away from the asymptote unless something gets moved crazy. Look, right? 1 away from the asymptote, same thing. All right. If you find your first point to be crazy away from the asymptote, you did something wrong. All right. So our point is normally at 1, 2 right here. So if I were to do a vertical flip at 1, 2, it should be at 1, -2. I then do a horizontal flip. Instead of being at 1, -2, it's at -1, -2. All right. I would then have to move to the left 2, 1, 2, which put a point right here. All right. And then I need to move up 2, which means I'm going right there. All right. And the graph looks like that. All right. And my points are, like I said, -2, 1, and -3, 0. All right. So let's just talk about how we got those points again, just to make sure. So we started here. All right. 0, 1 gets flipped to 0, -1 right here. When we flip it horizontally, it stays there. We move to the left 2, and then we moved up 2. All right, that's how we got to -2, 1. All right, for our other point, we start at 1, 2. All right, we did a flip down to 1, -2. I then did a horizontal flip to -1, -2. I then moved to the left 2, and then I moved up 2. And that's where we got to -3, 0. And that's how we got our graph. All right. Now, our basic shape is normally like this. It makes sense that it's going this way because we have a vertical flip, and then we have a horizontal flip. All right. And that's our shape. All right. So you can always tell by looking at the flips of what your shape should roughly look like at the end. All right. So to finish this off, our domain is -infinity to infinity, and our range, it's below, it is -infinity to our horizontal asymptote, which in this case is 2. All right. So now, hopefully you guys have a good understanding of this. You get to practice some of the rest on the homework worksheet. And if you have any questions, please reach out. All right. Hope you guys enjoy the rest of your day.